So when it comes to an electron microscope, see, we learnt about compound microscope, correct? So in compound microscope, we had combination of lenses and the image was being magnified, correct? Now in an electron microscope, instead of light, we use electron, or you can say a beam of electron, because we just saw that electrons can also behave like a wave, right? Now, how the experimental setup goes is we have an electron gun, and see, electrons are charged particles. So if I have to bend them or if I have to change the direction, I can use either electric field or magnetic field, correct? It's very easy. So what we have is something called as condenser lens or condenser magnetic lens. It's basically magnetic field. Okay, now see, this is how it goes. So you have an electron gun and then magnetic condenser lenses, right? Now what happens? Electron comes out as a beam. Okay, an object will be kept. So as the electron hits the object, it's going to behave like a wave, correct? So as it behaves like a wave, these condenser lenses acts like optical lenses, what we saw. Okay, so it behaves like an optical lens, and every time the electron has to change the direction, we change the magnetic field, because changing magnetic field is very simple. You change the electric current, what is given, then the magnetic field will change, right? So we get an image. Okay, so we'll get an image. Now the good thing about electron microscope is that what we know is lambda is 12.27 by square root of V, correct? Now voltage is nothing but the electron gun's voltage. Now I can give 1000 volts, 10,000, 100,000, how much ever voltage, that's not going to be a problem, correct? So I can give a lot of voltage. Say I'm giving, let's say I'm giving a voltage of 60,000 volts. Okay, so 12.27 by root of 60,000. This will give us approximately 0.05 angstrom. See, if lambda is lesser, then remember resolving power, D was inversely proportional to lambda, correct? So if my lambda is 0.05 angstrom, just imagine what will be the resolving power. See, just to compare between compound and electron microscope, a compound microscope can see up to a small amoeba, okay, amoeba, or even it can see about a nucleus. Okay, nucleus is the biggest part of the cell, so it can easily see a nucleus. Electron microscope can even see the DNA, because electron microscope has the magnification power which is 10 to the power of 5 times the compound microscope. If a compound microscope can see the nucleus of a cell, the electron microscope can see the DNA in the cell. Even till that much, the electron microscope can magnify, because I can change the wavelengths to how much ever I want depending on the voltage I am giving. More the voltage you give, lesser will be the wavelength. So lesser the wavelength, more is the resolving power, correct? So this is the reason electron microscopes are used in figuring out the distance between two molecules and two atoms. That is, see, we saw that in nickel crystal the distance between two atoms is 0.91 angstrom. How will we get to know that is the distance? We use electron microscope. Okay, so we use electron microscope and then we figure out the distance between two atoms, like how far those two atoms are or how far those two molecules are. Okay, so electron microscope has a lot of application, like lots and lots of application. Anything has to be resolved into a very high extent, we use electron microscope. Okay, so this particular electron microscope is one of the applications of a matter or a particle behaving like a wave. Okay, so applications are endless. This is just one of it. So go through the internet or go through any other books, figure out different applications of it.